Alright, nothing new today. Just wanted to spend as much time as we need to going through as many questions as we can. So, questions from the homework 9.3. It is due tonight. 9.3. And awkward shuffle dance up here.
This is never explained. Since you like to record all of it, you know?
Oh, I need to post the videos. I'll do it later. 40.
Maybe just number 40.
I think it is. Is that the fourth? Yes. I don't remember that one.
I have it, and I think I've only done the ones that you've done on the board.
Okay. I'm happy to do it again. I don't mind.
Yeah, you can go ahead. That
Okay.
was very long.
Ready? So we have in total 3 sets of formulas from this section. We have the double angle formulas, the half angle formulas, and the reduction formulas. In this problem, the instruction states, for number 40, rewrite the expression with an exponent no higher than 1. So the issue with this problem is this 4. Since it's a power, I'm going to use the reduction formulas to fix it. Now, there were a reduction formula for each individual formula that we had in the class. So example, sine squared, cosine squared, and tangent squared each had their own reduction formula. The sine squared formula was 1 minus cosine of 2 theta all over 2. The cosine squared formula was 1 plus cosine 2 theta all over 2. And the tangent formula was 1 minus cosine 2 theta over 1 plus cosine 2 theta. So what we're going to do is I'm going to try to algebraically manipulate this problem until I get it to match one of the forms that's on the board, and then use that form to reduce the power. Let's look at the first step. Step 1. I'm going to take this sine of the fourth power. Remember, this is just sine function as a fourth power. I'm going to rewrite it as sine squared of 8x squared. This is using an algebra trick from Algebra 1, where I take a power and I split the power apart. Now, normally in Algebra 1, you put the powers together, but we can also just split them apart algebraically for the same results. So now I have something being squared, which I can use to fix this formula here. I'm going to take this formula, rewrite this now as, algebraically, sine squared of 8x times sine squared of 8x. Remember, something being squared just means to multiply it by itself. So 8 squared means 8 times 8. 7 squared means 7 times 7. 6 squared means 6 times 6. Sine squared of 8x means sine times 8x times sine of 8x. I still haven't met the criteria of the problem. The criteria of the problem says reduce it down to a power of 1. So I'm going to take each of these and now apply the power reduction formula. The power reduction formula says sine squared of theta, so in this case my theta will be my 8x. I'm going to now write it as 1 minus cosine of 2 theta all over 2. Here we go. This becomes 1 minus cosine of 2 theta all over 2 times 1 minus cosine 2 theta all over 2. Now for me, I'm going to simplify what I can, but there will be a point where I stop and say I think this is good enough. The book goes a slight step farther than I do because for the book they want to make sure to put it down to its lowest possible form. But keep in mind the criteria of the problem is very straightforward. It says get this down to a reduction using these formulas where I no longer have any powers greater than 1. So what I will do is I'll simply simplify this down to 2 times 8, which will give me 1 minus cosine of 16 all over 2 times 1 minus cosine of 16 all over 2. I think that's pretty good. It's a good version. It's fine. It's not the greatest because I could do more algebra to get this even more simple, but it is at least meeting the criteria as necessary. Now, the book's version looks a little different because what the book did is it then went ahead and FOILed the top out into one complete fraction, which forces another piece to appear that has a square in it. So the book's version continues and FOILs this thing out. So the top, when I FOIL it, becomes 1 minus 2 cosine of 16x plus cosine squared of 16x all over 4. If you FOIL the top and multiply the bottom, you get this function, which I notice has a square in it now, which is unfortunate. Because the problem specifically says no power is bigger than 1. So then the problem uses the cosine formula here to get rid of that cosine squared. And so the book takes it one more step farther and says 1 minus 2 cosine of 16x plus, instead of cosine squared, it writes 1 plus cosine of 2 times 16x all over 2. So just doing a substitution using the formulas we have on the list. And the book just simplifies that down into one big fraction. Like I said, I'm fine stopping up above, and whenever you take your test in this section, I'm fine stopping there as well. As long as you have applied the rules correctly when they need to be applied, and you've gotten down to dimension has less than the power of 1. So that is a fine solution. The book solution looks a little different, but not too far. Let's see, the final book solution would be 2 minus 4 cosine of 16x. Let's see, that's going to be, no. 3 minus 4 cosine of 16x plus cosine of 32x all over 8. Just simplifying that fraction down farther. Like I said, you've seen where I'm accepting up the answer, whereas the book just tends to go farther. That was number 40. Other questions?
What about number 5?
Number 5? Yeah. Sure. Sorry, do you have it? I'm going to go ahead and scroll down. Number 5. Okay, number 5 says, if sine of x equals 1 over 8 and x is in the quadrant 1, find the exact value of sine of 2x, cosine of 2x, and tangent of 2x without solving for x. So, if sine of x is equal to 1 over 8 and x is in quadrant 1. Okay, we're going to find 3 pieces for this problem. We're going to find sine of 2x. We'll then find cosine of 2x. And then finally, we will find tangent of 2x. So my recommendations were the same as for the last section. This is really common when you're given a trig function. So if you look at a problem and you're given one of the trig functions already, like we have here, sine of x is equal to 1 over 8, it is incredibly common to go ahead and take the time to figure out what the triangle looks like, and then use that triangle to solve the rest of the problem. So we'll take those first couple steps we've been doing so far, which is to draw a triangle with the information given in the problem. So in that case, my x will be here, got my right angle, and then I apply my 1 over 8 as evidenced by the problem. My opposite would be a 1. My hypotenuse would be an 8. My missing side, using Pythagorean's theorem, square root of 63. From here, I can actually begin to answer the question itself. The question says, what is sine of 2x? Well, if I go to my double angle list, according to my double angle list, sine of 2x is 2 sine x cosine x. So everywhere I see a sine of 2x, I can replace it with 2 sine x cosine x. But the nice thing is, this triangle will tell me both sine of x and cosine of x, because that's what the picture is for. So what I do is I now use this triangle to plug in 2 times the sine of x being opposite over hypotenuse, so 1 over 8, times the cosine of x, which in this case would be square root 63 over 8. Now, before I continue, I want to make sure x is in a specific quadrant, which can affect how the trig functions act. Since x is in quadrant 1 tells me that all trig functions are going to be positive, which means that both of these problems should be positive 1 and positive 63. Always take the time to check that, even if you're sure. Just take the moment, because the most common mistakes come from that issue. And then finally, the last piece is to simplify this. So I take 2 times 1 times square root of 63, so 2 square root 63 over 64. And then I start simplifying. 2 over 64 is 32 on bottom. Square root of 63 is 3 square root 7. And that is my solution. So I get 3 square root 7 over 32. A calculator can be of assistance with the last part of it, but a calculator cannot help you with the first part. If you do not know how to use the formula, if you do not know how to generate a picture, then you cannot solve this problem. I'm going to go on and do cosine. Cosine is very similar, but it has a different formula. So with this one, it's about figuring out the right formula. So in this case, I use 2 sine x cosine x. For the next one, I will use probably the first formula, cosine squared minus sine squared. So come in here. The formula for cosine of 2x is cosine squared of x minus sine squared of x. So I take that, I plug them in, and now I plug in my values and see what happens. My cosine function squared, I go to my picture, my cosine function is square root 63 over 8, and we are going to square that, minus my sine function, which is 1 over 8 squared. I'm reusing the sine here and the cosine here down in this problem. I don't need to double check which ones were positive or negative because I already did that. And now I just simplify. So I take this problem, I square the top, I square the bottom for both pieces until I get my solution. I get 63 over 64 minus 1 over 64. I then subtract those two. 63 minus 1 would be 62 over 64, or 31 over 32. God bless you. Now to find tangent, I could use the tangent formula. I hate the tangent formula, so I avoid it when possible. I will instead use the reciprocal, or in this case the quotient identity, which tells me that tangent is just sine over cosine. So to find tangent, I'm going to come over here. Tangent of 2x.
Are there ways to write that besides the 1 minus cosine or 1 plus cosine?
Not for the double angle. For the half angle, there's multiple ways to write the tangent one. For the double angle, there's multiple ways to write the cosine one. Cosine 1. Okay. Double check me on that. I'm 95% sure because I'm pretty sure the only one for tangent is 2 tangent of theta over 1 minus tangent squared. But it's the half angles that have multiple ways to write it. So I'm going to write tangent of 2x is equal to sine of 2x over cosine of 2x. If I did part A and part B correctly, then I should have both of those numbers so I can plug them in and get the solution. This would be 3 square root 7 over 32 over 31 over 32. The 32's end up canceling, giving me the final solution, 3 square root 7 over 31. Done. What's neat to point out here is if you look at the 3 answers we got, we did the signs correctly on each one. And if you look at the 3 solutions we got, this answer is actually in the first quadrant, which is kind of neat. Right? Because all 3 trig functions are positive. Meaning we doubled an angle that was in the first quadrant and it just stayed in the first quadrant. That's actually pretty common. If I pick an angle like 30, if I double it, it's 60. That's still in the first quadrant. But if I pick an angle like 60 and double it, it ends up in the second quadrant. So you have to be very careful. That's why the formulas are there to help us. But I still have to know how they fit together. Questions? Number 5. What was that, right, Scott? Good. I do hate you.
I think I kind of forgot what he said, but I just heard myself
Like
right.
secant of x, I keep forgetting to put the c. So I'm just writing like over.
Wow,
and
Valerie,
by
you're writing
accident.
6 over and over again on
Yeah,
paper?
by accident.
It's okay. I call it secant of x. And the reason I told you not to do sin x, cos x, and tan x is because how do you pronounce S-E-C-X? Well, D6.
Yeah, I keep accidentally forgetting to put the c. And it just like over and over again, I'm writing sex all the time.
Wow.
Yeah.
Probably have something to say, but I do not. Any other questions?
That's crazy.
Okay. So 10, I'm going to approach the exact same way. But in this case, they've already given me cosine of 2 theta. So I'm going to use this to try to find all the other trig functions, okay? Now, in talking with Daisy 2 days ago, we actually tried number 9 together, and we ended up going in a whole different, terrible, bad direction on how to solve this problem. So this one, let's actually do it the correct way this time. And let's see if we work on it. Yeah.
I thought we were doing number 10 right now.
We are, but they're very similar. Number 9 and number 10 are very, very, very similar. Okay, give me a moment. We were having a debate after school as to whether or not this problem was asking us to find sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and cotangent of x. Because if you read the problem, that could be what it's asking you to do, but it could also be asking you to find sine of 2x, cosine of 2x, and tangent of 2x, as well as the others. Cosecant of 2x, secant of 2x, and cotangent of 2x. It wasn't incredibly clear from the problem itself as to which one you're supposed to find. So what I did was, I applied rule number 3, right? Pay attention to your solution. I checked the back of the book on rule number 9. And rule number 9, it specifically says, let's see, 9.3, problem number 9. Yep, okay. It wants these answers. Okay?
Which is much easier.
Depends on how creative you're going to be. Right?
I mean, all those are formulas, right? And all these would just be looking at a trig.
Actually, they're both all formulas.
Huh.
I'll show you. Ready? Number 10. Number 10 says, we are given 2 pieces of information. We are given one trigonometric function that cosine of 2 theta is equal to 1 over the square root of 2. And we are given that our theta is between 180 degrees and 270 degrees. First thing I want to point out here is this should indicate that we are in quadrant 3. If you're between 180 and 270, we are in quadrant 3. Now, this was the part we had the most trouble with yesterday, was that in order to find my solutions, I am actually going to use the half angle identities. That seems a little weird, but it actually works very, very, very nicely because of how half angle identities work.
Yeah,
Take a look.
We want just normal cosine, but we have cosine of 2.
That's right. If I want just cosine of theta, right, what I really want is to do cosine of 2 theta and cut it in half. Which this tells me I'm doing a half angle formula. I'm trying to cut 2 theta back into theta. The reason why that's so nice is because all the half angle formulas just use cosine. Here we go. Defined, example, sine of theta. So what I do is I use the I use the sine half angle formula. So I'm using the half angle formula on the sine function. That is the square root of 1 minus cosine of 2 theta all over 2. This is just a variation on how to write the half angle formula. If you replace your alpha with 2 theta, you get this formula. It's the same formula. But notice that this one contains cosine of 2 theta. So I can just plug in and get my solution very, very, very quickly, as opposed to the alternative, where I have to take it at a much slower pace. So I'm going to take this function. In order to find sine of theta, I'm going to do plus or minus big square roots 1 minus cosine of 2 theta. Cosine of 2 theta was given in my problem as 1 over square root 2 all over 2. Now, in an effort to save some headache, I'm going to immediately reach for a calculator. Okay? I'm going to immediately reach for a calculator and write plus or minus and type that thing into a calculator, because my goal with this problem is to get the right solution, not to worry about doing the algebra part of this problem.
Why you don't want to just, do it without a calculator?
I really don't. You want me to? Alright, give me a second. I just won't show my math, because I'll just be lazy.
If you can do that entire problem in your head and get it to, like, I don't know, just get it right, that'd be pretty cool.
Should be that. Oh, but I'm getting
Giant
old.
curved sine with a little itty bitty 2 minus 32. Got it.
Yeah, I didn't remember if there was going to be something above. I don't know.
Do you want the decimal?
Please. I'm not sure about the decimal. Alright, what we get? 0.3826. Now, what's key to note is that we are in quadrant 3 for the original problem, and we have cut the angle in half. So let's investigate what happens if I cut an angle in half when I'm down here in quadrant 3. Let's pick a couple angles in quadrant 3 and see what happens when I cut them in half. 240. If I cut that in half, where do I go? Second quadrant. I get to 120, right? 225. A little tougher. If I cut that in half, I get 112.5, which would be still somewhere in the second quadrant. 210. If I cut that in half, I get 105. That's still in the second quadrant. Even if I choose like 181 and cut that in half, I get 90.5. I'm still in the second quadrant. So no matter what I do, my answer should be in the second quadrant. I'm using logic to determine a sign here, because I should not have two answers here. So in this case, because this forces it to be in quadrant 2 sine is positive, which means the correct solution for this problem is the positive 0.3826.
Cool.
Now we'll do the cosine, and then we'll do the tangent. We did it a little different way when me and Daisy were doing it, and it did not come out this easy. We tried forcing the double angle formula to work. It got really nasty really fast. And as I told you in class, like sometimes when you do a problem and it's starting to get nasty, maybe it just means you went in the wrong direction. And we just tried to power through it and ended up taking like 20 minutes to do the whole problem. It was bad. So this was a lot faster. All right, let's do part 2. So we've got the first answer. Sine of theta is equal to positive 0.3826. Now we're going to do cosine of theta. To do cosine of theta, what I'm going to do is I'm going to again use the half angle formula. So cosine of theta is equal to plus or minus big square root of 1 plus cosine of 2 theta all over 2. Again, I'm just modifying the half angle formula. You have all these formulas available to you, and you can modify them algebraically to do what you need them to do. That's the trick with some of these problems is you're not just going to use the formula, you have to modify the formula first for it to even work. So now I just plug in my pieces again. So cosine of theta is going to be equal to plus or minus big square roots 1 plus cosine of 2 theta. Cosine of 2 theta, as we already said, was 1 over the square root of 2 all over 2. So again, we plug the information in. We should get a number like 0.8717, somewhere in there. Plus or minus. Still good here. Probably pretty bad. What did we get, Evan? 0.8717? That was actually pretty close. 9328? 38. Good. Notice it tells the plus or minus. I have not fixed that yet, so once again, I'll go back. As a reminder, we just discussed how quadrant 3 problems end up here in quadrant 2. If I'm in quadrant 2, sine's the positive one, so what tells us about cosine? We got to use negative 0.9238. Now, to find the tangent, once again, I would cheat. I would do sine divided by cosine. Just divide these two numbers and get my tangent value. So for tangent of theta would be sine theta over cosine theta. Since I already have those two, I would just plug them in. So I'd plug in the sine value, which was 0.3. Oh my god, I can't remember. 3826. Thanks. 3826 divided by negative 0.9238. And whatever that is has got to be the tangent value. And the nice thing is, once you get to here, I don't have to worry about the plus or minus because this formula doesn't have a plus or minus in it. I can just divide the two. As long as I did part A and part B right, this one has to be right. So it's a nice little cheat. When we get there, Evan. You're close. Negative. Should be negative. All right. And then define cosecant, secant, and cotangent, which is one of all 6. I would use the reciprocal identities to find the rest. So define cosecant. I would use 1 over sine. So 1 over 0.3826. To find secant, I would do 1 over cosine. And do 1 over negative 0.9238. And then do cotangent, I would use the inverse of tangent. So once you get a couple of them, like the rest just kind of all fall in, because I can use properties to find them rather than having to worry about anything else. Now the other way to do this problem would be to what we tried yesterday, which was to draw a picture of cosine of 2 theta and use to estimate the values of cosine of theta. It takes a lot longer. It is far better to try it this way and see how they fit together, because they really do fit nicely, if you can see the connection. Now, again, one last time, we had to use a modified version of the half angle formula, which is allowed, as long as I modify everything the same way. In this case, I doubled every angle in the half angle formula, and the formula works. So, and for your reference, this problem actually had one very similar to it, 3 pages back at home. It was example 8. Very similar. Usually, if the problem's really tough, they try to give you a hint with an example in the text. Usually. That was number 10. Other questions? I know these last homework assignments have been kind of long. I was talking during the first club with some of these guys. For the next couple sections, we're going to just do odds. It'll be a similar setup where we'll try to split it apart, but in the end, it will only be odd problems assigned, and we'll do even problems in class.
If you are in the building, push your person down into the office, please.
Alright. I know there's been a lot of problems the last couple weeks. I apologize for that. I did not plan ahead properly, so I will make amends and do it properly next time. Alright? Any other problems?
What time does class get over?
10:42. We have 9 minutes left. Not about 9 minutes late line.
So 9 minutes to sit here and do nothing? That's pretty nice.
Much like some days for you, yes.
And I get to go into seminar and do nothing at that well.
Hey, my seminar's not even here. I got seniors.
I hope there's like 1 year so you actually have to do something.
I will have a party without them. Party with nobody. So, for number 9, the big difference of number 9 is they did not give us the cosine. Oh, this was because they don't. Oh, right. In that case, it's actually not too bad. I thought for some reason on 9 you go with something else. Okay, number 9. To help get us started, we are given that cosine of 2 theta is equal to 3 over 5. And 90 degrees is less than or equal to theta, less than or equal to 180. Just like before, if I want to find sine, cosine, and tangent, I'm going to use the modified versions of those formulas. So I'm going to modify the half angle. So what I do is sine of theta is equal to plus or minus the square root of 1 minus cosine of 2 theta all over 2. Well, I have cosine of 2 theta, so I can plug that into the formula now. So I end up with equal to plus minus big square root 1 minus 3 over 5 all over 2. And then you just solve. In this case, you get plus or minus square root of 5 over 5 as your solution. And then because you are in quadrant 2, it should be positive. So equal to the positive square root of 5 over 5. Yay! Make it look 5. Yep. That first step's wonky because it has to use the modified formula. So this does not perfectly match the one on our cheat sheet, but it is still the same formula. So for cosine, yes, I would do plus or minus square root of 1 plus cosine of 2 theta over 2, which would give me plus or minus big square root 1 plus 3/5 over 2, which would be plus or minus 4 square root 5 over 5, I do believe. That's not right. That's not right. Plus or minus 2 square root 5 over 5. There it is. Yes. You're in the second quadrant. Second quadrant should be negative. Yes. Who's calling? Where's Malden? You know. Yes. 9 times did that. The rest just straight up use the regular formulas. So thank you for asking that. Others. Make sure on 9 and 10 you find all 6. That's the problem. Yeah.
Yeah, it's allergies.
What's that like?
What are allergies like? Or can't breathe out of your nose?
I'm not gonna lie to you. This kind of
I only get allergies in the fall when all the leaves fall.
Get them both.
I get them in the fall, but I get them worse in
My eyes are itchy.
I don't get them in all through summer. It's just in the fall when I'm inside and I don't do anything. So.
Ran out of allergy medications. So.
Just remember, plants are attacking your face at all times. Yeah.
Must be allergic to tree pollen. Got allergies this time of year.
Yeah, allergies.
Could be was it haze seed?
Also mold.
Yes, it is that. Remember?
In the fall, there's
I
big
had
mold
bugs.
spikes. In the spring and summer, there's big pollen spikes from the trees.
I see it in the fall.
See, I feel like
Not as
it'd
bad.
be mold in the spring as well, because like everything's like getting rained on, so like you're more likely to get mold because things are wet and decomposing.
I don't know. My allergies go throughout the summer. So.
Yeah, sorry.
You know, in the fall, because all the leaves fall down, and they're like all decomposing as well. And it's very easy for them.
Yeah, then you can go jump in the leaf pile and go around and really get your allergies on.
Oh yeah.
That's
My throat's scratching. My nose is running.
Oh, my cousin decided to like rake up a big pile of leaves, and his uncle left one of the rakes in the pile of leaves. He was fired 16 stitches. It was pretty cool.
Ow. I bet that felt good.
This new dog was sushi.
So again, that was number 42. Once again, just make sure that you have to rewrite it. You have to write it so we can actually use the formulas. I can't redo sine to the fourth until I rewrite it as sine squared times sine squared. And so again, the algebra tends to be the tipping point for a lot of these problems. If you understand the algebra well and can apply it to a trig problem, then it's not so bad. But if you can't do the algebra part of it, the trig part becomes almost impossible. So, other problems from homework?
Can you do 46?
46? Happy to. Alright, 46. I also recorded the questions from first class. I will try to get all those posted during 6 o'clock today. 46. Sine squared of 2x. Now, the instructions say, reduce the equations to powers of 1, then check the answers graphically. Alright, let's do it again. So again, this time, what I have to think about this is, again, I have to think about this in terms of the functions that I have in my paper. I do not have a function that simplifies sine squared of 2x, but I do have one that simplifies sine squared of theta. That's what I will use to simplify this problem when we get back from lunch. Huh? Want to pick up where we left off? So, on number 46, we've got sine squared of something. It says in the problem to reduce this times, but no longer has any version that is a power greater than 1. So, what I first recognize is that this is just, again, sine squared of something. I'm going to use my rewrite formula using this concept in order to get it into a formula that's no longer in the power of bigger than 1. So come over here. The rewrite formula for sine squared is 1 minus cosine of 2 something all over 2. Normally that thing is x, but in this case my centerpiece is not an x, it's a 2x. So I just replace that with a 2x and start simplifying. So I get 1 minus cosine. 2 times 2x would be 4x all over 2.
I need the following students to the office. They have won some awards at FBLA. Andrew Watkins, first place in economics. Erica Medina, fourth place impromptu speaking. Matthew McCall, first place journalism, first place political science, and second place economics. And Kylan Sermon, place accounting, and fifth place is direct to the business. Come to the office, please, get your medals.
Okay, so as we just discussed, on 46, the big piece to note is that I have to recognize this is just another formula, and just the inside piece is a little bit different. That does not change the process. I'm still using the same formula, but now I have to incorporate that information into my new formula. So it used to be sine squared of theta equals 1 minus cosine of 2 theta over 2. Now, just wherever I used to have a theta, I replace it with 2x. So it becomes 1 minus cosine of 2 times 2x all over 2. And I simplified 2 times 2x give us 4x. That's our solution. And as with the previous one, I'm going to check this graphically to make sure it's actually right. So I'm going to type this into the calculator and see that these two graph the same. And they should. So sine squared of 2x should equal 1 minus cosine of 4x all over 2. So I have this problem. Sine squared of 2x should be the same as, in reaction, 1 minus cosine 4x all over 2. And yeah, they do match. So this must be right. Again, the goal is we use the formula in a unique way, plug the information we have in the problem into that formula, and then simplify what we can off grid. That was number 46. Any other questions in the homework? Okay. I will relax.
Oh, 10.
Number 10? Yeah. I like number 10 now. So for those of you that don't know, they used to after school to get some help on some of these problems, and number 9 was one of them. And number 9, we went through, like 20, 25 minutes just on number 9?
That was annoying.
It was annoying. And so, after a little bit of time, yesterday, I figured out that there was in fact a much easier way to do it. So what I want to point out is, first of all, what they told us on number 10 is that we have cosine of 2 theta is equal to a fraction, 1 over the square root of 2. And we were also told that theta is somewhere between 180 and 270 degrees. Or in other words, that theta is in quadrant 3. So, in order to do this problem, I'm actually going to be forced to use a unique version of a formula. We want to find out what sine of theta is, what cosine of theta is, and what tangent of theta is. What I want to point out here is that second one. We want to know what cosine of theta is equal to. What I want to point out here is that the angle we are now looking to find is actually half as big. We are given cosine of 2 theta, we want to find cosine of theta. If I want to find an angle that's half as big, I can use a half angle formula. This is a big thing to think about because the half angle formulas are written in a weird way. They're written as cosine of alpha over 2, or sine of alpha over 2, or tangent of alpha over 2. But if I replace that with the information in this problem, something cool happens. Here we go. So for this problem, what I'm going to do, I'm going to use the half angle formula for all of these. Here we go. In this case, 2 theta I'm going to think of as alpha or x or anything else. It is the angle that the problem started with. I want to find an angle that is half as big, so I use the half angle identity. The half angle identity states that sine of alpha over 2 is equal to the plus or minus square root of 1 minus cosine of alpha all over 2. That is a formula we have written on the board Monday, Tuesday, and Wednesday of this week. What I want to point out, though, is that for this problem, if I replace alpha with 2 theta, the formula changes a little bit. Take a look. So what I'm going to do, everywhere there used to be an alpha, I'm going to replace with 2 theta. So the first piece, sine of alpha over 2, becomes sine of 2 theta over 2, or just sine of theta. But it has to do it everywhere I see an alpha, I'm going to replace it with 2 theta. So over here, I have equals plus or minus big square roots 1 minus cosine of alpha. Everywhere I see an alpha, I replace it with 2 theta. So I do cosine 2 theta. All over 2. And so you can see that this is a variation on the double angle formula, just kind of written backwards. What's nice to point out here is we actually know cosine of 2 theta from the problem. So finding sine of theta is really easy. I just plug in the number I know. Here we go. Sine of alpha is going to be equal to plus or minus big square root 1 minus cosine of 2 theta. Cosine of 2 theta, it said in the problem was 1 over the square root of 2, all divided by 2. At this point, when I was doing this problem, I was like, I've spent way too long helping Daisy, and then I had to redo it myself. So I was like, I'm not going to algebraically simplify this. I'm going to grab a calculator, type this in, and see what I get. And when I did, I got an answer that was plus or minus 0.3825, something pretty close to that. Feel free to double check me in case I'm remembering wrong. But note, like, this is an application of the formulas we have used so far in this class. We are allowed to use the formulas as much as we wish to in as many ways as we can creatively think to use them. If we can think of the half angle formula and just plug something else into the half angle formula, the formula is still true. It's just now I can now use this information to solve it. So before, if I just look at the half angle formula, I can't use anything I started with. I can't use cosine of 2 theta because I don't have a cosine of 2 theta anywhere in my problem. So I have to rewrite first, simplify, and now I can plug in stuff. Last thing, I have a plus or minus solution. Just like before, I want to make sure to get the correct solution. There's 2 of them as an option. So I come here. I am between 180 and 270 degrees for my theta. So I come over here. Between 180 and 270 is in this bottom left-hand corner, which you'll notice tangent is the one that's positive, which means everything else has to be negative. So the correct solution for this one is negative 0.3825. I am done.
It's 27.
27, not 25. Thank you for having me fix that. 27. 27. Thank you. Yes, by comparison, this was significantly shorter. Now, I think we still got the right solution when we did it the other way. It was just a pain because we used a different formula that took a lot longer. But in Trig, this becomes a common theme, and I thought math becomes a common theme. You're given formulas, but not necessarily told the only ways to use them. The half angle formula worked here because we wanted to find an angle that was half as big. But half as big has different meanings. Half of 2 gets reflected theta. Half of 1 gets subtraction. So, like, there's different ways to use that information and write that information. Now, the reason why this problem is so nice is because we're given the cosine function. When we do the other values, they all have the cosine function in them. So we can actually do the rest of them very quickly. I come here to do cosine of theta. The formula is very similar to the sine theta formula. Just instead of being a minus, it is a plus. So 1 plus cosine of 2 theta over 2 would be our new modified formula. It's the same formula, but now instead of an alpha over 2, I replace the alpha with a 2 theta, and now every other piece has to move to match it. So again, it's not the exact same formula, but functionally it acts the same. So it's totally usable. And now I just plug in the information I need, and I get my solution. This becomes plus or minus the big square root of 1 plus cosine of 2 theta from the problem was 1 over the square root of 2, all over 2. And the value we got here was roughly equal to plus or minus 0.9 something. 9235. I don't know. At this point, I'm just making up numbers. But it should be pretty close. And then, of course, last thing, I have two solutions. I only need one of them, so I double check. I have a positive and a negative. Remember from the instructions said this is in quadrant 3. I go to quadrant 3. In quadrant 3, tangent's the one that's positive. And so I just use the negative solution as my solution. Yes, sir?
This is quadrant 3.
So that's the big thing, is that up here, they told us where theta is, not where 2 theta is. It says theta is in quadrant 3. And so when I check quadrant 3. Whereas on previous problems, they told me where theta was, and I was looking for 2 theta, so I had to logic around to try to figure out where it's supposed to go. No, this time they straight up told me, hey, we're looking for theta, and theta's right here. So I liked this one whenever I realized what the trick to it was, because before that, it was kind of a pain. Now the problem did say to find all 6 trig values. Don't forget, if I want to find the other ones, I can use the reciprocal identities, or I could build a triangle and find the rest. In this case, don't forget that tangent of theta would be equal to sine over cosine. So I use that with the 2 solutions I already had to find the solution for this problem. And to find cosecant, secant, and cotheta, or cotangent, I just use the reciprocal identities to find the rest of them. Again, once you find out the first 2, which are totally reasonable with the information they gave us in the problem, we can find the rest of them pretty easily with the reciprocals.
What is 53 asking?
Sure. Before I go to 53, are there any other questions at number 10? I have given you 2 of the solutions. The other 6, go ahead and find using the reciprocals and the quotient rules. 53. The following exercise algebra found the code function only to have a sine and or cosine, then check the answer right after each equation. Yes. Ready? 53. So excited. I like 53. Yes, that's what I did. Because the calculator is good there, right? So for cosecant example, I plugged in 1 divided by the decimal that is sine. For secant, I plugged in 1 divided by the decimal that is cosine. And for tangent, I did 1 divided by the decimal that is tangent. Okay, 53. I'm given sine of 4x and told to rewrite this in terms of sine x and cosine of x. Now, there is no functional rule that will let me rewrite this the way it is written right now. I have no rule we've talked about that lets me go from sine of 4x to anything else. So, as we discussed multiple times in this section, I will make it my first goal to algebraically rewrite this problem so that I can make it work better. I do not have one that will solve me for sine of 4x. I do have one that will solve me for sine of 2 times something. It's called the double angle formulas. In this case, I will use sine of 2 times 2x. Functionally, these are the same things, but the second one is now in a form that I can now use a shortcut on. Here we go. In this case, my 2x becomes like a theta. This is the equation, sine of 2 theta. And as we know from our cheat sheet, the double angle formula, sine of 2 theta is equal to 2 sine of theta, or in this case, 2x, times cosine of theta, or cosine of 2x. So we've managed to take this problem and rewrite it using the double angle formula. Again, I couldn't do that from the beginning because it wasn't in a form that allowed me to. It was sine of 4x. So I rewrote algebraically, and now I can. Alternatively, you could have done 2x plus 2x and used a sum formula. You could have done 5x minus x and used a difference formula. There's a lot of formulas you could use. This is one that just happened to match with this chapter's materials. But notice, my problem says to get it in terms of sine x and cosine x. This is not in terms of sine x and cosine x. It is in terms of sine of 2x and cosine of 2x. So I'm going to fix this by rewriting this term and by rewriting that term. And when I do so, everything around them needs to stay constant. Here we go. The 2 will just stay at 2 up front. The sine of 2x is now replaced by 2 sine x cosine x. So everywhere there used to be a sine of 2x, I replaced with the double angle formula 2 sine x cosine x. The cosine formula, cosine of 2x, I have a few versions I could use. I'm going to choose to use the first one, which is cosine squared of x minus sine squared of x. You notice now that everything is in terms of sines and cosines. Yeah, some of them are squared, but that's okay. And so this is one version of the solution. Now, I think the textbook went a step farther and went ahead and multiplied these three things together. But in the end, this did exactly what it was supposed to do. I have taken this function, rewritten it in a form that contains only sine of x and cosine of x in the problem. I would consider this to be a fair solution. Do note that there are a couple of pieces that are weird. There's a 2 out front. The 2 out front came from the first use of the sine of 2 theta formula. And then this 2 comes from the second use. The cosine squared minus sine squared, that comes from a third use. And so you have to use it and rewrite it each time there is a form that needs to be written. Now, is it going to check my graphing? I will check my graphing in a moment. But I promise it is correct. Again, the back of the book we have a slightly different version of it where it can throw it out, but it is correct. Here we go. I'm going to graph sine of 4x. I'm going to graph that thing. My equation. Sine of 4x is this equation. Ooh. Ah. My second equation is 2 parentheses 2 sine of x cosine of x times cosine squared minus sine squared. Yeah, look at that. A perfect match. So beautiful. So elegant. Other questions?
51.
51. Okay. 41. Let's make sure we remind ourselves about 53. I cannot rewrite, or cannot do the original problem, so I rewrite it. When I rewrite it, I have to use the correct form for that new equation. And then I have to check, did I actually meet the criteria of the problem? I did not, so I rewrote again using the formulas a second time. And now we're looking at 51. 51 is cosine squared of 2x times sine of x. 51. Cosine squared of 2x times sine of x. Now, this problem says on 51, reduce the equations to powers of 1, then check the answers graphically. This is actually a pretty straightforward one. So what I'm going to do is I'm going to use the perfect square formula to simplify this piece only. The sign is going to stay on the outside because it doesn't need to be reduced. It is already a power of 1. So let's reduce it down. The cosine equation is equal to, so again, times sine of x over here. And the cosine equation I'm going to replace with the new version using the power reduction formula.
Christopher Y, please come back to the office.
1
Christopher Y,
plus
please come back to the office.
Cosine. Now don't forget, the equation for cosine squared has a 2 already in it. So the fact that it's a 2x actually makes this 2 times 2x all over 2. Again, I took the cosine squared reduction formula. Say what, Michael?
I was asking if it was like 50.
Yeah, very solid. Okay, now from here, I'm going to take this function. I will actually simplify it a little bit more, but not much. I'm going to simplify the 2 times 2x, and I'm going to distribute the sine function into one big fraction, and that's going to be the answer back to the book has. Equals. So I simplify the 2 times 2x, so I get 1 plus cosine of 4x all over 2 times sine of x. If I'm doing this problem myself, that's probably the solution I stop at, because that's a good solution. If I'm doing it like for a textbook, I'd probably go ahead and algebraically simplify it one step farther. That means I would take the sine of x and distribute it to the cosine of x and to the 1 using the distributive property. So I get sine times 1 is sine of x. Sine times cosine is just sine times cosine. And that's all over 2. This is the equation the back of the probably gave. It's the same equation as the previous one, just distributed. Like I said, the algebra tends to be the sticking point for a lot of the trig stuff. And once you plug everything in, like, there's not any more trig to do. It's just algebra. And just like the previous one, I will graph both of these to verify they are in fact correct. I have met the criteria that all powers are now less than or equal to 1. So, go ahead and do it. My original equation was cosine squared of 2x times sine of x. I'm going to graph this equation and see if they match. Alright, I have cosine of 2x squared times sine of x. Oh, look at that. So pretty. I know some back rows don't kind of look like that. Alright. My other version was a big fraction. I had sine of x, so sine of x, plus sine of x times cosine of 4x all over 2. Look at that. A perfect, pristine match in every way. And once you get used to the idea that we are just algebraically manipulating a formula, these problems are not as tough as we want them to be. But that's still a lot to ask. You're just plugging into a formula and then you have to algebraically simplify it. That means you have to find the right formula. That means you have to plug in that formula correctly. That means you have to do the algebra once you've done that. None of those steps are easy by any means, but they always follow through that order. We look for a formula, we try to find that formula that matches to the problem itself, we plug into that formula, we simplify as far as we can go algebraic. The only exception to that rule is if you have to first use a triangle to find something else. And then still, you're still following the same basic rules of find a formula, plug into the formula, simplify. That was 51. Do you believe? Yeah. Any other questions for the homework? As the nails will be ringing in about 10 minutes. Any other questions? 55. I'll go ahead and say one of the classes requested because these last 2 homework assignments have been very long. I have said that I will not take off points if you happen to skip some of the even ones. I encourage you to do all the odds because that way you can check your results, but I will not take off any points if you skip some of the evens in order to get this in on time. And next week, I will only assign the odd problems. You will do the even problems as examples in class.
So if we already have some evens, then just skip the rest of the evens.
Feel free.
Okay.
I didn't think about it. I thought about doing it at the end of the last section, and then I was on autopilot on Monday. I started the signing. I'm like, wait a minute, didn't I say I was going to try to change it? And so I'll go ahead and make that change right now. And next week I will try to do it a different way. And if I forget, somebody please call it out, because otherwise we'll be stuck doing more problems next week too. So please remind me next week as well. Next problem was 53? 55. That's like 55? Ah, one of the identity problems. Yes. I'm so glad somebody asked. 55. Okay. 55, I have sine of 2x is equal to 2 tangent of x over 1 plus tangent squared of x. Okay, double check that I wrote it down correctly. Looks pretty good. All right. I'm going to take a moment. We need to figure out how to solve this problem. So, it's a proof problem. We've talked about proof problems many times the last couple of weeks. So let's talk about our steps again. Step 1, we're going to look at one side at a time. Try to pick the most complicated thing you can and work from there. Step 2, look to factor, distribute, square, combine fractions, a bunch of algebra that you could do. There's a whole field of algebra we can work with. And don't forget, we can also apply algebra to our formulas now. Step 3, pay attention to your solution. Make sure you're working towards that solution specifically. And then step 4, if all else fails, convert everything into sines and cosines. For this problem, if you choose the wrong side, you actually get in trouble pretty quickly. So let's add to that first question. Which side should we start with? Right-hand side is the correct choice. It is the more complicated side and has the most things we can do with it, and actually has already, very nicely, a trig identity in it. So, 2 tangent of x over 1 plus tangent squared of x. We are starting with the left-hand side. No, we are starting with the right-hand side. Let's see if we can make the match. Okay, look at that equation. I got 2 tangent of x on top. I have 1 minus tangent squared. Apologies, Ms. Brewer is calling me. I assume it's probably something important. Hello, Ms. Brewer. Yes, ma'am. Okay. Okay. Oh my. A 1 final pass for seniors who came today? Ooh. Ooh. To be exempted, not to get 100%. To be exempted. I will think that through and talk to my people. Personally, I like the idea, but I will talk with my people. Okay.
I got it. Yeah. We can make fun of a garage that come to school today.
If they skip today, does it count against their attendance?
Yes.
Still.
Okay.
We got 4 minutes for this problem. It will not take all 4 minutes, so I want to answer that question quickly. They're thinking about doing a exemption from 1 final pass for anybody that showed up today. That was a senior specifically. So you might be thinking ahead to yourselves, hey, maybe next year I might have a class I don't want to have to take the final in.
All of those.
Now, the only thing that does not count for is, I know she'll say it if I ask her, it would not count for dual credit classes because we can't get around that. That's not our choice. The college has to approve that. So, but it would be for like any other class that you're taking. You just be like, no, I feel like it.
What if you're not taking it?
Yeah.
Like
Just take finals. Just as a
Like,
show.
Even still, like
Wow.
it's still,
Like it anyway.
sadly, because it's still a dual credit class, they count everybody, even if you're not taking it. That's the only way they can ensure good standards.
And it's 10% of your grade if you don't, right?
Correct. What do you guys think?
So you're asking us
that
the
count
seniors that showed up today.
If you, let me ask it this way. If you heard this was a thing, would you show up next year instead of doing senior skip day?
Yes. Because I was paying my finals anyway.
Okay. Very simple, very simple. If this would be an incentive, meaning you would still show up to school if you got this, please raise your hand.
If you have A's, you don't have to take your finals anyways, right?
Okay.
It wouldn't matter.
How many of you would not care? You'd be like, heck no, I am skipping no matter what. You cannot offer me a thing. Alright, let's go ahead and work on this problem. I circled something.
Just lost all our faith in us.
No, like, I'd rather you were honest. Like, come on. Alright, guys. I circled something specific. 1 plus tangent squared. My memory is a buzz. No.
That's secret.
Did you just say sex squared?
Yeah, I did.
I don't judge.
Yeah. That's a murder.
Engineer's Hannah.
I did have somebody.
Oh,
I did have somebody yesterday make the comment. They were like, I may need you to check my homework, and I was like, why? They were like, I'm pretty sure I forgot to write the C on every problem. I was like, and I looked. She had. It was super funny.
The C, like, on what do you mean?
Secant.
6.
So she had no sex.
And it was squared sometimes. I don't know how that works.
Times 2.
That's
Sometimes it was 2 sets.
really funny.
Sometimes it was sex over 2. You know.
You should have let
It's
her
horrible.
leave it. Did you let her leave it?
I might take a picture of it and save it for later, posterity's sake. All right, so we are now here. We need to take the next step. So I pose to you, how should we proceed from this point? I like the expansion thought. Okay, we're going to apply step 4. We're going to convert this thing into sines and cosines and see what happens. So let's take this problem. What happens to tangent? So I'm going to leave it 2 where it is. What happens to tangent? Sine over cosine. What happens to secant squared? Squared. All right. That's looking pretty good. I noticed that I have something on top and on bottom in the same position, so I can see something eventually going to cancel. But I'm actually going to go ahead and do KFC at this point. I think it's a good time to do it, and I'm going to. Here we go. So the first thing we did was we used a Pythagorean identity. And then here we convert. All right, now over here, I'm going to use KFC. This becomes 2 sine of x over cosine of x times. Remember, the top stays the same. We keep the top. KFC says we flip the bottom and change the multiplication. So we flip the bottom. So instead of 1 over cosine squared, it becomes cosine squared over 1. Now, what can we do next? Cancel the cosine. What's left behind? Okay, we're now right here. We got rid of a cosine by just canceling on top and bottom. And we now have 2 sine x cosine x. What happens now? If we look at our solution was to get sine of 2x. If we look at our page, 2 sine x cosine x is sine of 2x. So we are now finished. Yay. Notice again, we used multiple different formulas from this section and previous sections and followed our 4 big steps. If you have your homework done, please turn it in the front. If not, your classroom is fine. Yes. You have one of these. I've already gotten 3, so feel free. It's the reflection page from yesterday. If you had a good time or learned something interesting, you can write it down, and I will give you 5 bonus points.
All 4 people next to each other.
Yeah, some of us didn't go.
What did you do during the afternoon? I went home.
Nothing.
We got here and left the
Talk about what you didn't catch.
Okay. I went home. I took a nap and then I went to work.
Yeah, talk about what you didn't catch, okay?
I ran.
Send it to me in the classroom. Or send it to me email, it's fine.
Wait, what is it?
You did pictures, huh?
Yeah.
Go.
Really just like this.
You free share now?
Just the last thing that I had.
Fill it out and send me a picture. Or send me an email about it. Dirty dog. Anything you want. Give it to me. Nice job, Andrew. That looks good on you, man.
That's right.
Need some
Forgot I had
more.
it on.
Need some more, man.
Have any plans for the weekend, Douglas?
Yeah, a few. We'll
What
see.
are they?
Have fun.